Welcome to A Picture in 1,000 Words, brought to you by the Dunlap Institute for Astronomy and Astrophysics at the University of Toronto. In this series, we break down some of the most iconic images from space from the perspective of an astronomer, like me. My name is Mobdi Rahman, and I am a scientist at the Dunlap Institute. If you're watching this live, please feel free to throw a couple questions into the live chat that's somewhere over there, and we'll try to get to a few at the end of the episodes. But let's dive right in, into Hubble's Cosmic Reef. So this image is an ode to the Hubble Space Telescope. The Hubble Space Telescope was launched in the 1990, and so it's 30 years old as of this year, and it doesn't look a day over 29. And it's been helping us understand the universe near and far. And this image that was basically remastered for the release is called the Cosmic Reef because it kind of looks like an underwater world. You could imagine, a couple of fish swimming along, bubbling up, and that, kind of looks like a jellyfish. It's all very undersea theme, but in space. So the picture itself is a star-forming region, so much like the Orion Nebula that we've already talked about, but this is much larger and much more energetic. So we're seeing stars shining their first light, and some of them taking their last gasps as well. So this region is in a galaxy not so far away. It is actually outside of our own galaxy. So, outside of us and our nearest 400 billion closest star friends, in another galaxy that's orbiting our own called the Large Magellanic Clouds. And you can see this with your naked eye if you're in the Southern Hemisphere. So a shout out to our South American, African, and Australian friends. You could go out tonight and, if you're in a dark enough place, see the Magellanic Clouds. It's about 160,000 light years away, and that sounds small, that sounds far, but the size of our galaxy is actually about 130,000 light years away. So if you imagined, if this was our galaxy, this galaxy would kind of just be hugging it very closely and orbiting around it. It's very close. It's like our little tail almost, and this is where all of this is happening. This region is about 1/3 the size of the moon, making it about 500 light years from edge to edge. So it's a big region, and just as a reminder, about a light year is about the distance between us and our closest star. So what we're seeing is a ton of different stars in this region. The main colors that you're seeing here are all taken from the Hubble Space Telescope. So that blue is actually optical light, or the visible light, or the kind of light that your eyes can see. It's blue if you had massive eyes that could look out into space and detect all of that light. That red, very similar. The green, we see little bits of green over here. That's also very similar to the kind of light that our eyes would be able to see. But the difference is when you're up in space and you have a massive mirror like the Hubble Space Telescope does, which is, I believe, something like 2.5 meters wide, where our eyes are only about 5 millimeters or so, you can collect a lot more light. And that's the big thing that telescopes do. It's not so much about zooming in and being able to give us magnification. It actually is that it can just collect more light, see things that are much dimmer that our eyes wouldn't be able to see. And Hubble has done that very, very well over the past 30 years. So what is this image? So right over here, we've got this area that we're going to call the reef. It looks a little bit like a reef. You can imagine random fish swimming by and going scuba diving into this thing, but it's much, much further away. And what's going on here is that there are a large number of stars being born, so you can see them over here. And the way to interpret this image is that there's this big, huge cloud of gas, and these stars have broken through a bubble. So if this was face on and you had the stars here, what we're seeing is this. That's what we're seeing. But all of these stars are being newly born in this area, and they are lighting up and blowing up this entire region. So first off, let's take a look at this blue stuff over here. So that's on the edge of that shell. So again, if the stars were like this, it would be sort of in here. And that stuff is really intensely being turned into a plasma. So the blue that you're seeing there is oxygen. All of that is oxygen gas that is been heated up so much it's a plasma, and it's glowing blue very intensely. Now, some of this stuff, some of that light also is making it out to further regions into space. And into this gas, and that's turning this light into, it's making this light a little weaker, but it's still hot. There's still a lot coming through there, and it's still lighting all this up. And all the red that you're seeing here, and they added a little bit of orange, that is coming from hydrogen and nitrogen gas that's glowing, much like in your fluorescent bulbs. It is, just takes the energy from the light of those stars and makes it glow, and that's what we're seeing here. And all of these stars that you're seeing here, just the light alone, that's right, the light alone, it's pushing all of that gas away. It's heating some of it up, but it's also doing a ton of pushing. And this is one of the ways that new stars affect the regions in which they're born. So this process of forming new stars is a fundamental way that we think about galaxies, right? One of the ways that we compare galaxies is how many stars they're forming. Are they forming a lot, or are they forming a little? This is similar to when you think about cars. How fast does it go? Does it go faster, or does it go slower? This is a fundamental process in the way that we understand how galaxies work and how they evolve. And so in this one region, this is actually producing a ton of stars. This is actually our our biggest, most intense region of star formation anywhere close to us. And it's happening in a piddly little satellite galaxy of ours that's kind of dragging along, but there's so much going on here. And one of the reasons why all of these stars, they're pushing this out. And one of the reasons that we're trying to understand what's going on here is that as this gas cools, all this gas has a lot of mass in it. And so there's a lot of gravity that is just trying to pull it in, and that pulling it in is the process through which we have stars that are being born. All that gas gets denser and denser and denser. But when you have that first generation of stars that are formed, and as they're heating up that gas and as they're pushing things out, they're starting to oppose gravity, and they're starting to stop all of this rest of this gas that preventing it from falling in and forming new stars. So this balance is a big part of understanding how stars form and the rate at which they form, and why certain galaxies form stars in certain ways. It's all just this massive cosmic balance. So let's now turn our attention to this blue little jellyfish looking thing here. I do love it because it does actually kind of look like a jellyfish, even though it's, millions of times larger, or at least millions of times larger. And the key to understanding this is this little thing here. That is a Wolfray star. So that is just a fancy word for a very massive star that is near the end of its life. So that thing is dozens of times larger than our sun, and it's about 200,000 times brighter. And it is basically taking its last breath. It's really hot. So that thing is anywhere between dozens to multiple dozens of tens of thousands of degrees. And it doesn't really matter what unit. It could be Celsius or it could be Fahrenheit. When it's something that hot, you don't really care. It's just very, very hot. The units between Celsius and Fahrenheit don't really affect it. And what it's doing in its last breath is it is shedding much of its mass. The winds that are coming from this star, so the star is producing large amounts of winds, and it is blowing off much of its outer layers, like this ultimate cosmic Weight Watchers or Atkins diet, where it's shedding somewhere near half of its original weight. And all of that material is what you're seeing here. This is all material that has been shed off of this star over the course of tens of thousands of years. And this material is really hot. It's coming from this incredibly hot star. So it's turning, what we're seeing here is it's too hot for hydrogen to be in a plasma. Hydrogen's already turned into plasma at this point. It's turning oxygen into a plasma twice. It's so hot that oxygen can't keep a hold of two of its electrons, and that's what we're seeing here. So that's why it's so vividly blue. Eventually, the star that's going on here, it will take its last breath, and it will go supernova. So that's just a cosmic reminder that the bigger you are, the harder you do fall. So let's take a look at some of the questions in the chat. So we have Margaret asking, do you mean that the photons push the gas out? That is correct. That is exactly what's happening. So oftentimes you think of the photons, from this gas being absorbed by other gas, or the photons from the stars being absorbed by other gas, and then the heating up of it pushing it out. But what I'm talking about here is that there's so many photons, so many particles of light, that the particles of light themselves are pushing the gas. Just when they get absorbed, they have a certain amount of momentum, and that is pushing that stuff out, and that's what's happening here. And that's just kind of crazy. That's not like a phenomena that we really see here on Earth. There's just nothing that's ever really that bright. So Ben's asking, is the light pushing out the cloud the same idea as a solar wind? So yes, in some cases. So certain solar winds are driven by what this is called in scientific terms is radiation pressure. So some winds are dominated by the radiation pressure of the star. So just that is pressure that's caused by the photons of that star, the light from that star being absorbed and pushing things. And this is what's happening. This is what you're, so it happens on a smaller scale around the sun, and that solar wind comes, and we see a little bit of that in the Aurora Borealis and the Aurora Australis if you're up north or very far south. But this is on a much, much larger scale, where instead of just, loose matter that's around the star, we're seeing things that are much, much further away from the star being blown out. And that's what we're getting. But that's all the time we have for today. A special thanks goes out to Heather Bricey, who suggested we take a dive into Hubble's Cosmic Reef. And also a special thanks to all of the thousands of scientists and engineers who made Hubble work over the past 30 years. You guys have done a lot to really help us understand the universe as a whole. Be sure to like, share, and subscribe, especially on YouTube, catch some past episodes, and definitely leave a comment down in the box below to recommend which pictures you'd like to see next. Thanks so much.